Very good morning, friends. Myself, Dr. M.H. Annaya. And friends, in today's video, we are going to study the development of a triangular prism. A triangular prism will have three rectangular surfaces on its lateral side and two equilateral triangles at the bottom face and at the top face. And now the question reads like this: a triangular prism of side 40 mm and height 60 mm rests on one of its triangular faces on HP. So we got a triangular prism, it is resting on HP. How it is resting? With a shorter edge of the base parallel to VP and nearer to it. So friends, let us write down the position of the triangular prism which is resting on HP. So friends, it is a triangular prism having side equal to 30 millimeter, and one of the sides of that is parallel to VP and nearer to it. So friends, this dimension is 40 mm, and in the front view the height of the solid is given to you. So you can write down what is the front view for this, for the given height. So friend, this is how the prism looks in the front view. This has got a height equal to 60 millimeter, and the side length of this side is equal to 40 mm. This is given in the question. So we will name the corners of this as A, B, C. Then here A dash, B dash, C dash, O dash, O1 dash. Again for the bottom face, A1 dash, C1 dash, B1 dash. Marking here AA1, CC1, BB1. This is the position of the solid, that is the triangular prism, resting on its base A1, B1, C1 on HP, and with one of the side or one of the rectangular faces, because this line represents the side AB and also rectangular face which is parallel to VP. I will write down here AB parallel to VP and nearer to it, or one of the corners away from it. Now friends, for a triangular prism, assuming it is not cut by any section plane, the development is going to have three rectangles, vertical rectangles. So adjacent to this figure, I will construct a rectangle having sides, three rectangles, and the measurement of each rectangle is equal to, this is 40 mm and this height is equal to 60. I will write down here, this is 40 and the total length is 40 into 3, because it is a triangular prism. If it were a rectangular square prism, we would have marked it as 40 into 4. Friends, now it says in the question, a hole of 30 mm diameter is drilled perpendicular to the axis and normal to VP. So there is a hole drilled perpendicular to the plane of the board, and the diameter of that is equal to 30 mm. So friends, I will mark the center of this, because the hole is being drilled here, and draw a circle of diameter equal to 30 mm. This is 30 mm dia. And friends, now we have been asked to draw the development of this, showing the hole, presence of hole in it. So we will have little higher height, 80 mm you take. This is 80 I will take. instead of 60, let us have 80. So 80 mm and this is 40 mm mid height. The hole is drilled. Friends, this is 40 mm, right? 30 mm, So friends, practically what happens, this is how a triangular prism looks in the front view. In the front, there is a hole drilled like this. This hole is drilled perpendicular to the plane of the board, and the axis of the prism and that of the hole, they meet at the midpoint, that is at a height of 40 millimeter from the base. And friends, after you keep it open, it has to be something like this. So in this diagram what happens, the side AB of the prism or this rectangular face A1, B1. Before that, let's mark it starting from point A. A, this is B, C, and A. For the bottom face, you will have marking A1, this is C1, this is B1, and this is A1. Friend, this hole is drilled exactly in the center of the vertical edge CC. So vertical edge CC is here. And what happens here, friends, if you just project it downwards from the edge of the hole, it will meet here. Similarly, this side, it will meet at a similar distance. And this is how the hole is being drilled. Okay, friends. Now what happens? On this rectangular face A1, B1, the diameter of the hole drilled is on a flat surface. So on a flat surface which is parallel to VP, if you drill a hole, you can see the true shape of that hole. Here the rectangle A1, B1 is parallel to VP and a hole of diameter lesser than that of the width of that rectangle is drilled, and hence on the face AB, A1, B1, that rectangular face, you are going to get a circle exactly. And see, so friends, I am going to produce all these lines from the top and bottom of this circle. I am going to produce like this. Friends, here what happens? On AB, A1, B1, we will have this circle written. So exactly on AB center. So this is center of that AB. So exactly in the center, we will mark the center, and with this center and radius equal to the radius of the circle, we are going to draw a circle, because this is seen as a circle since the width of this, I will make it a little smaller. So friends, here you are going to have a circle in the center, and locate this center, and to this side you are going to have a circle. This is going to be exactly a circle. So I will write down here, this on this face, it is a circle. That is, if I show you practically, on this face AB, you are going to have a circle like this. A circle in the rectangle A, B, B1, A. A1, B, B1, you are going to have a circle. And let me complete that part of that. So all the borders of the figure are intact. So you can show completely this border. And here, let us see what happens to the other part. Friends, this part is on this C. When you spread it open, friends, the back, the front side, it was like this, a hole was like this, and when you stretch it like this, whatever the hole it was built on that center line, that is CC, it gets elongated and looks like an ellipse. So you are going to have a circle on one of the rectangular faces, and between the other two faces, you are going to have an ellipse having minor dia equal to diameter of the circle, major dia depending on the dimension. Friends, how to locate that is the question now. Friends, here on this is going to be the two extreme ends, that is the minor axis of the ellipse, and here we will have a central line here. So we are going to get an ellipse here, and I will tell you how to draw that ellipse. Friends, you can see here, this is on AC. You can mark this distance from A on AC. You have the distance marked. Draw a vertical line from there. And friends, this distance you have marked is this gap. And if I represent this as M, say if we call it as M, and this is the distance M we are taking. So friends, on this line, you get a point here where it is meeting the center line. Similarly, at equal distance on the other end, also you get another point. So there are 4 points to draw the ellipse here, but minimum 8 points are required to complete the ellipse manually. So let us draw 2 more. So 4 more points you will get. See, you had 1, 2, 3 and 4. And now we will have four more points. How to get it? Simple, friends. You write a diagonal here or a line inclined at 45 degrees to the horizontal. You get a point here. Take that point to the end. So where is this point? Suppose if we call this point as K. K is here. Just write a vertical line from there. You got this point K. This K here. Mark the distance on AC nearer to A. On AC nearer to A. So that is, it is going to meet here. On AC, you have to mark that nearer to A. So somewhere here you get that point. So this is the point where the horizontal drawn from K is meeting this vertical drawn from this edge. So similarly, at equal distance on the other hand, you will have one more point. So friends, you got 6 points. Produce it downward, you will have one more point here. So friends, you got 1, 2, 3, 4, 5, 6, 7. Produce it to the right side, you will get a point. Friends, after locating these 4 points, you can draw a 45 degree line here or any line, say 45 degree line. Locate these 2 points plus these 2 and draw a smooth curve passing through all these points. Friends, this is the ellipse you are going to get on the other 2 sides. So friends, let me complete the complete development of the prism with the hole, and you will have to mark it dark here. This will be thin line, a dark line here and a dark line. Friends, this figure is going to be an ellipse, and this is going to be a circle. And friends, finally, if you just open and see, this is how exactly the development looks like. So in the first rectangle you have a circle, and between the last two you have got an ellipse, and the minor axis of the ellipse is equal to the diameter, and the major axis depends on the diameter of the circle. This is how practically you can see. So this portion is visible, I have shown by dark line. These edges I have shown vertical edge. This is the second vertical edge BB. This is the vertical edge AA. And the figure in the right end will give you the complete development of the triangular prism with a hole, and this hole is seen as a circle on the flat surface which is parallel to VP. It will be a circle, and on these two surfaces it is seen as an ellipse. The minor diameter of the ellipse is equal to the circle dia, and the major ellipse or the major axis will be dependent on the diameter of the circle. Friends, I hope this presentation was interesting, and if you like this video, do share with all your friends. Have a nice day.